Okay, last unit of the semester. We're going to talk about polar coordinates today versus rectangular. We've already handed in our, I guess we used to be a tide. This is our daylight lab. We've already handed that in. If you'd like to do the galactic battleship game, could be fun on a Zoom on a Friday night. We aren't going to be able to get into it today. Okay. So your entire mathematical career, you have dealt in rectangular coordinates. Meaning to get to a place on your coordinate grid, you would go left or right, and then you would go up or down. So -3, 4 lands you here. This is P. So a rectangular coordinate looks like this. The left, right, and then comma, up, down. Polar is on a circular grid instead of a rectangular grid, and also has two directions. One is your radius and one is your theta. So we'll do theta in a little bit, but if I wanted to get to that same place, my radius is my hypotenuse. So this is a 3, 4, 5 triangle. I know that my radius is going to be 5, so I would go out 1, 2, 3, 4, 5 in a positive direction because it's +5. And then I would rotate whatever this theta is going to be, and we'll find that in a bit. So polar versus rectangular. Okay, so let's do a little graphing. So we're going to graph point P. I would like to graph, let's do 4, 5 pi over 6. So it's kind of graphed here. 4 would be out right. 1, 2, 3, 4. And then I would rotate positive 5 pi over 6, and I would land on the fourth rung. 1, 2, 3. See, I didn't do it right. One, 2, 3, 4. There we go. That's point P. Okay. Can a radius be negative? Definitely. So what if I did -4 and I wanted to end up in the same place? Well, -4 means that you're going to the left, and I want to rotate this way. Well, that would be negative, so that would be negative pi over 6. Those are both coterminal. Okay. You could also do, let's find one more coterminal. We'll do it in red. What if I did positive, oh, that was stupid. Okay. What if I wanted to stay at the 4, but I wanted to rotate in a negative way? Now this should be a nice circle, and it's not. But what if I wanted to end up here? I think that's one full 6 pi over 6 plus a pi over 6, so that would be -7 pi over 6. All polar coordinates, all coterminal. R can be positive or negative, theta can be positive or negative. The other two are just helping prove that point, okay? Now, let's go in a different way. Let's say that this point here, we're going to graph 1, 2, 3, 4. We'll say that P is at 4, pi over 4. So it went 4 out and then rotated pi over 4. Okay, what would the rectangular be? Okay, well, couple of things that we know. We know that this is a right triangle with a hypotenuse of 4. And I know that theta is pi over 4. Well, pi over 4 is a degree. Isn't that 45 degrees? And if it's a 45, 45, 90, then to find the side, you're going to divide by √2. So this point right here, if we were on a coordinate plane, as a rectangular, would be 4 over √2, 4 over √2. So just to reiterate, to write a polar, you've got a radius and a theta. To write a rectangular, you're going to write your x value and your y value. Both are coterminal. Did I spell that right? I've got an extra like thing there. It's not supposed to be. Okay, we've got more. I don't think I said this in the first one. Your 0, 0, your origin in polar is called a pole. I don't think I said that, but I'm saying that now. The rest of this slide is good practice for graphing positive and negative radius with positive and negative thetas. This slide is basically saying that if you have a polar coordinate like 3 pi over 4, and we went 3 to the right and then graphed that point P, we keep using P, it doesn't have to be, at pi over 4, that there exists more coterminal points. You see that 2 pi k that I underlined? If you add a 2 pi k to that coordinate, you could find another coterminal point. So if you go all the way around the circle and added 2 pi to pi over 4, you'd get 9 pi over 4. Just a point that's coterminal. That's all the slide says. To go from rectangular to polar, that's what I'm going to focus on this slide. So we have a rectangular point. This is x, y, and we're going to switch it to radius theta. Okay, so I have a triangle, x, y, and r. So r squared is going to be equal to x squared plus y squared. So to find r, we're going to use Pythagorean theorem. So if we have our x and y coordinates, we're going to take x squared and y squared, add them up and take the square root. That'll give us the r. To find the theta, I need a trig function that uses x and y, which would be opposite over adjacent, which means we're going to use tangent. So if we use the tangent of theta is equal to opposite over adjacent, so that'd be y over x, that means theta is going to be the inverse tan of y over x. Okay. So let's go ahead and try one of these. Let's try this very first one. So this coordinate is in rectangular. I want to change it to polar. So let's graph it first, find out where it lives. This looks like it's in quadrant 4. So I've got 2 and negative 2 root 3. So first let's figure out what our r is going to be. So r equals the square root of 2 squared plus negative 2 root 3 squared. So I think we're going to get the square root of 4 plus 4 times 3, 12, square root of 16, 4. This looks like a 30, 60, 90 triangle, but let's see. Okay, so we need r theta. Right now we have 4 comma something. Okay, then we're going to figure out tangent. So tangent of theta is equal to, here's theta, opposite over adjacent. Opposite over adjacent. This should look familiar. Our 2's are going to cancel, and you get negative root 3. Tangent is equal to negative root 3 in, well, it's negative in quadrants 2 and quadrant 4. I want the one in quadrant 4, right? Because that's where it lives. So I think you get root 3 over 2 over 1/2 at pi over 3. So in quadrant 2, it's 2 pi over 3, but that doesn't work. That's in the wrong quadrant. I want the one in quadrant 4, so that would be 5 pi over 3. So my coterminal angle, or my coterminal point in terms of polar is 5 pi over 3. Oh, okay, so this starts the beginning of your homework. You're supposed to plot this point and then give 3 different expressions. So find 3 coterminal angles to pi over 3, or find a radius that's negative instead of positive, to find 3 different points that are all at the same place. This slide, you're converting rectangular to polar. We just did that in the last slide. So these problems give you a little bit more practice with that. Okay, I skipped past the battleship slides. Maybe we'll do, let's do number 18 together. I'm going to just do it over here so we have more room. First, we're going to graph 2 pi over 3 would be out 2, and you swing to pi over 3. Okay, so we need to change that to rectangular. So let's make this triangle. I know this hypotenuse is 2, and I know that this is pi over 3. I'm going to cheat though. I know pi over 3 is 60 degrees. So I'm going to switch this to a 30, 60, 90 triangle. So hypotenuse is 2. That means that the short side would be on the 60 degrees. So that would be half of the hypotenuse. And then the long side would be 1 root 3. So we have our rectangular coordinates. Right 1 and up root 3. So give some of these a shot. That concludes the homework, and there's a key also in this folder if you want to check your work. I will be on Google Meets if you have any questions. Thanks, guys.